Hi, you guys. I'm making a little video to help you guys out here for this week's assignment. I'm on page 4.1, interpreting and constructing isolines. So an isoline is used to connect points of equal elevation. A contour line is used to connect points of equal elevation. So we're going to be learning about contour lines. Contour lines give you insight to the topography, so basically the lay of the land, the difference in elevation. Examine the map below, taking careful note of where each geographical feature is located. So an overhanging cliff indicated by dotted line. Here's the overhanging cliff. So this dotted line right here, you see where it becomes a dotted line? That would be an overhanging cliff. You wouldn't want to get too close if you were up here. A gentle slope with widely spaced contour lines is here. This is indicating a gentle slope. All these contour lines that are spaced further apart. Right? A closed depression. This is our closed depression. These are called hatch marks. These little ticks, I labeled them ticks up here, but they're hatched marks. A steep slope by close contour lines. So right here is a steep slope. You see how close these lines are together? That means that's going to be a really steep slope. Let's keep going to the next page. Be sure to read all of this information. Watch the video on constructing contour lines and connecting points of equal elevation. This is also a diagram. These are both the same. This one just has the lines drawn on them. Be sure to read all of these. These are going to be very important to complete the assignment. Contour lines are drawn as solid lines. Sometimes they're black, sometimes they're brown, which never cross. They connect points of equal elevation. Contour interval is the distance between the two lines, between the two contour lines. The contour interval is usually noted at the bottom of the topographic map. Index contours are thicker lines that indicate like each 5 or each 10 or each mark. So say we're going 5, 10, 15, 20. In between the 5 would be a thinner line, 6, 7, 8, 9. 10 would be thicker. 11, 12, 13, 14 would be thinner. 15 would be thicker. We'll see examples of it. Be sure to read all this information. Okay, now let's look. Here's a really basic one. Elevation is 720 feet, 730, 740, 750, and it's a closed circle, so that indicates a hill. And the elevation is rising this way. This is a lower elevation. This is higher. Here's a depression with the hatched marks. That means a depression in the ground, which is kind of like a hole. It'd be a hole. Okay, now here are two different pictures. This is the side profile, as if we're looking at it, standing next to it. This is as if we're looking down at it. So again, these are the same elevations, 0, 10, 20, 30, 0, 10, 20, 30. And remember the closed circles indicate the top of a hill. So we have two little hills here, two little points of higher elevation. Make sure you read all the important information. Contour line rules. Here's some great examples of topographic maps. So you can really examine the lay of the land. I love this one because it's of Yosemite Valley. If you've ever been to Yosemite, then you know it's a beautiful place. Let's keep going. Here's another example. This is a really great example. Again, here's the side profile. And here it is with contour lines. So right here, look at this is steep slope. And right here's the steep slope. Look how close these contour lines are together. Right, this is more gentle uphill slope. That's why they're spaced wider apart. This is a gentle uphill slope. Right, and then we have a depression here, or we have a creek flowing through here. Here's where we have a depression. That would be here somewhere. You can tell ridges. Here's the ridges. Here's another simple example, just so you can really try to understand how these contour lines work. So we have 100, 200, 300. We have a little hill that caps off, and then a depression. This depression right here, or the hill right here, is going to be the same right here at 300 feet. And then it keeps going. So there's kind of like a little bump hill, a little bump on a hillside. And that's this right here, 100, 200, a little bump, and it keeps going. This is going to be the depression now, the example of the depression here. You can see how it has the hatchet marks pointing inward. That means it's going to be a hole instead of a bump on a hill. All right, so now we're talking about this part. So this one is the closed circle, and this one has the hatchet marks. It's also a closed circle, but it has the hatchet marks on the inside. And you can see how it goes down to 200. Okay, this is our first assignment. I don't think you should have too many problems with this, but let's go over a couple questions. There's only 5 here, and you're going to use this really basic map to figure them out. What is the contour interval of this map? The first question. Well, they make it really easy. Let's see. Here's our index contour. Look how thick that is. 550. And then if we keep going, here's 530, but look at, here's another line here. So 550, this must be 540, 530, 520, 510, 500, 490, 480. So the contour interval is 10. We're going by tens here. If you walked from Druid Stone to Upper Moor, would you be walking uphill or downhill? Druid Stone to Upper Moor. So let's find Druid Stone. So the elevation here is about 580. See how that goes through there? So if you walk from Druid Stone to Upper Moor, here's Upper Moor. Would you be walking uphill or downhill? Well, we're at 580 here. Upper Moor seems to be around 490. I'm going to let you guys figure that one out. What is the elevation at Sheepfold, where the word sheep is? Let's find Sheepfold. Here's Sheepfold. Here's the word sheep. Okay, so we got to follow this line. Be careful. Follow it carefully. Follow it carefully, carefully. There's our elevation. Okay, I'm going to let you guys finish off the rest. Let's go to the next part. So this one, I'm going to help you guys with all the questions here. So what is the contour interval of the map? Again, we got to figure that out. So, okay, let's figure that out. Here, we have our index contour. See these thick lines? We have 500. Here's 750. So we got to figure out what the contour interval is. 500. I'm going to guess 550, 650, 750. I'd say that that's right, 50. So let's try over here. 500, 550, 650, 750, 8, 850, 9, 950. We got 1,000 right here. So 50 is the contour interval of the map. What is the elevation of point A? Okay, here's point A. So let's figure out the elevation of point A. So our elevation of point A, let's go back up here. Estimate elevation between contour lines to the nearest half contour interval. Assume that the top of a hill is 1/2 contour interval higher than the highest contour line shown. So half higher. So 750, and we're going to assume that it is 1/2. So if it were a full 50, it would be 8, but we're figuring half. So in between 8 and 750 would be 775. 775 is your answer for point A. So what is the elevation of point B? Let's go to point B. Here's point B. Okay, so we know this is 500, right? Because look at how the line follow. This is all 500, 500, 550, 650, 7. So let's estimate in between 650 and 7. So 675. That would be our answer, 675. What is the elevation of point C? All right, where's point C? Okay, elevation of point C. We have 500, 550, 600. So I'm going to let you guys figure that one out on your own. Okay. Which lettered point has the highest elevation? Okay, well, let's look. Which lettered point? So this one is at 750. That's A. Right? Remember, points are closed. The top of the hill is closed. I'm going to go with E. Which lettered point has the highest elevation? Well, it's going to be E because we're already at 1,000 here. That means this is 1,050. That means this is 1,100. So it's going to be E. Which lettered point has the lowest elevation? Okay, well, we have 500, 550, 600. So that one's in the middle here between 550 and 600. 550, 6. Okay, that one's higher. 6, 650. I haven't found one that's higher than C. Well, let's go with C. Where is the highest elevation shown in this landscape? It may not be marked with a letter. What is the elevation of the highest location? So what is the elevation of the highest location and where is the highest elevation shown? Okay, so we need the name and the elevation. All right, well, I'm gonna let you guys figure that one out. This is 1,000. We have 2 more lines here. I'm gonna let you guys figure that out. The name is already here. So where's the highest elevation shown in this landscape? It may not be a letter. So let's use a name. What is the elevation of the highest location? So you need to figure out the elevation. Make sure to read the directions up here. Estimate the elevation, okay? What is the local relief of the landscape? The difference in elevation between the highest and lowest. So we got to know the highest. All right, we figured that out. And we need to know the lowest. This is going to be the lowest because this is 500 right here. And you can clearly see that it goes 500 all the way here, right? So this is going to be almost like a crevice. So this is 500, this is going to be 450, right? Because the contour intervals are 50. So you're going to minus 450 from the highest elevation, and that's going to give you the difference. That's going to give your answer. Minus 450 from what you got for the highest peak. Which lettered point is most clearly on a spur or ridge running down the side of a hill? All right, so let's look for a spur or a ridge running down the side of a hill. I'm going to give you guys a hint. It's in this half of the map, and I want you to do your best to figure it out. Is it possible to see D from F? Okay, let's go look. Is it possible to see D from here? I'm going to let you guys figure that one out as well. So if you imagine we're standing here at 556, 650, maybe in between 650 and 700, and you're here, can you see this point? If we're standing here, can you see this point? Is it possible to see D from B? Okay, so now we're standing here. We're standing here. Can we see D? So here we're at 5, 550, 6, 650. Now you have to consider what's in the middle here. Are we going to be able to see this spot? Same with the question before. You have to consider what's in the middle here. Will we be able to see this? All right, so think about it. Think about it carefully. What is the elevation at the bottom of the depression southwest of Pine Hill? Oh, I think we did that one already. What is the elevation at the bottom of the depression sound? Oh, no, we did not. Okay. So the bottom of the depression, this is the bottom of the depression. Okay, so let's figure out 5, 550, 6. Okay, so we're here at 6. Let's read up here to estimate the elevation at the bottom of the depression. Subtract half the contour interval from the elevation of the innermost closed, hatchered, depressed contour. So that's going to be, we're going to minus 550, 6. So this is going to be 5, 556. We're going to say this is 550. And it's going to be 525 because that's going to be half. So here it starts going inward. We have the depression. It's going to be 525. This is 550. This is 6. And we're gonna estimate half. This is going to go back to 550 here, and then half of that is going to be 525. How deep is the depression from the lip of the depression to its bottom? Well, if we're saying this is 550, 6, if this is from 6 to 525, that's going to be 75 feet, approximately 75 feet to 100 feet. So we're estimating this. In which direction does Rush Creek flow? Let's look at Rush Creek. Well, it's going to be flowing north to south. So you can tell by these V's right here, the V that it's making here with the contour line. Sounds a little difficult. So it's going to be flowing from the north to the south. Okay, I hope this helps you guys to understand contour lines a little better. Well, let me know if you have any questions.